Good afternoon, ladies and gentlemen. Thank you, Stephanie, for the introduction. I might use a couple of more words for introducing also our organization. Hans & Neumann Stiftung is a non-profit, impact-oriented implementer of project work in the coffee sector. We are very much hands-on oriented, working towards the empowerment of small-scale farmers in partnership with a number of roasting companies and other stakeholders in our sector. We have more than 20 years now in working towards development around coffee, and we have been formed by Neumann Gruppe, but by no means we are a member of Neumann Kaffeegruppe. We are an independent organization and a service provider to our sector. Let me come to the subject of coffee and climate, where I need to inform you, and I regret that I have to do that we are ignorant. We are very ignorant, and this has to do with our concepts. We are still struggling to get our head around the concept of sustainability, and now climate change is adding and brings us to the next level of complexity. Too bad that this comes at times when we need so much more coffee beans, as were pointed out this morning in the early session. Where do I have a pointer? Here it is. Climate models applied to coffee regions indicate that their suitability for growing coffee in the future might change. It might decline, and look at the charts that CIAT was producing within the scope of our Coffee and Climate Initiative for Guatemala, for Tanzania, and for Vietnam. I would just animate them to highlight the changes that are being projected to materialize in those areas in terms of suitability up to 2050. This was Guatemala. Now look at Tanzania. And the last is Vietnam. You see that the predictions are that those areas might shrink. They might shrink as much as 30% in terms of being suitable for growing coffee. The same trends actually appear in CIAT models that were also prepared for Nicaragua and for Kenya by other projects, as well as by Embrapa for Brazil, in particular for the state of Minas Gerais. Now, how accurate are these models, and do they really tell us the likelihood of the future trends? And is climate change really happening? Well, all good questions, but I don't know, I have to tell you. What we know for sure is that temperature is rising. And here's an observation which clearly underlines that trend. But in addition to observations, we also have hard evidence. We have measured evidence. We have measured evidence that temperatures worldwide are rising over the last 100 years, and we have measured evidence of the strengths of weather phenomena that are recurring more frequently today. I just picked out here the strength of hurricanes observed in North America over the last 50 years, and you clearly see how they doubled in terms of intensity over the last 30. I grasp from following scientific debate that unfortunately our scientists are almost every time caught by surprise when they compare their observations with the models that they were applying. Unfortunately, these models are always not telling the entire truth, and the real observations come much stronger, much faster than these fancy models project. In 2009, an interesting report came out by the ICO. A consultant was applying the IPCC models, IPCC standing for the Intergovernmental Panel for Climate Change, which produces reports on subjects and topics that are important for the United Nations Framework Convention on Climate Change, which led to the Kyoto Protocol. So quite an important intergovernmental body that was created. And these models, they project future for 4 different scenarios on our Earth. Scenario A1 is one that is characterized by more integrated, homogeneous world, rapid economic growth. Global population reaches 9 billion by 2050 and then gradually declines. Quick spread of new and efficient technologies. A2 is the scenario of a world of independent, operating, self-reliant nations. Continuous increasing population, regionally oriented economic development. B1, a model for a world that is more integrated and more economically friendly. Population and economic growth is as in A1, with rapid changes towards service and information economy and the introduction of clean and resource-efficient technologies. B2 late is a world more divided but more economically friendly, continuously increasing population but at a slow rate at A2, and rather local than global solutions for economic, social and environmental stability. Now these are the scenarios that are being used, and the driving forces are population growth, economy, technology and then energy, but also the use of agriculture. Applied to coffee, in all four scenarios, the consultant came to the conclusion that coffee sector will suffer from declining production and rising prices. Now this is already imminent, and we can see it in our coffee sector, that the examples are there. We look at Colombia in this place, where the La Nina phenomenon came in much stronger than expected and brought heavy rains to the coffee regions for 3 consecutive years. The spread of Roya was a big problem, and the decline in production. So these fundamentals make the market actually move in unprecedented ways by skyrocketing in the differentials for Colombias, but also for washed centrals. This definitely also was a challenge for the coffee sector, for everybody involved in trading operations, because replacements need to be used and new supply chains need to be established, which again added to cost. The vulnerability also is there for the farmer. And this chart shows how the weather phenomena, temperature, wind, drought and rain, impact income through, impacting yield and first and foremost production costs. And this situation definitely depends on the strength that the farmer puts behind its production systems, the resilience that the system might have. And if there is not appropriate technology being used at farmer level, then the income situation and the vulnerability of the producer gets very weak. Price development definitely might enable to counteract the decline in productivity and the decline in production. But again, in the case of Colombia, we have seen that even the extreme rise in differentials, which was 45% above the pre-shock levels, could not compensate for a 60% loss that many of the producers faced in the producing regions. Still today, in some regions, Colombian farmers are suffering from this situation. They still struggle with productivity. They struggle with an appreciation Colombian peso against the US dollar, and definitely also by falling market prices. So believe me, in some places in Colombia, farmers are losing money at these levels. Let us conclude. It looks like we are running into a serious challenge in our sector. Headlines that were collected from media over the recent past indicate that. And one was interesting, which just came out yesterday, which is from the Royal Gardens Kew in the UK, saying that climate change is seen to eradicating wild Arabica coffee. This is disastrous for our sector. It's disastrous because we will need the genetic information of the wild land races in Ethiopia and in southern Sudan to improve our genetic varieties in order to prepare new varieties that might be appropriate to be used in order to encounter the challenges confronted with climate change. So time is ticking. We also need motivated farmers, farmers that invest into coffee production, even in the times now where it's getting more delicate for them. And they need to produce more beans for our coffee sectors, for our markets, under scenarios for climate, which for climatic reasons might reduce the area that is suitable for growing coffee. And if we continue ignorant, there is little doubt that the future scenarios have a rather high likelihood to turn out just as projected. The good thing is that relevant know-how does exist in our sector. However, it is within individual institutions and within projects and not consolidated. So know-how can be found also in scientific reports, long and complex enough to make even a coffee addict to fall asleep over them. But know-how is there anyway. I assume that currently we would have about 90% already of the know-how which we require somewhere in our coffee sector. And for the remaining 10%, believe me, we have all the skills around the globe to work on them and to address them properly. So let us be smart and let us connect these existing experiences. And let us put the cards on the table and let us also be critical enough to ask ourselves what does work and what does not work. We need definitely to also identify the experiences which we need to generate in order to take us further. So work is required. On the other hand side, I also would argue that sustainability and suitability to address climate change, they are very, very much interlinked. Only sustainable production systems can be resilient enough to withstand the challenges that are associated with climate change. And only farmers that are well informed will be able to take the right decisions for them, for their families, and for their production systems. Production systems will also change. We will have to further develop them. Production systems that are not resilient to climate change are also not sustainable. Shade might definitely become an issue to reduce evapotranspiration in drier areas. Also, we will need shade in some places to just counteract rising temperatures in the production system. Rainwater harvesting might be a good technology to apply in order to prepare for drier periods, or establishing windbreaks to just be better prepared for strong storms and to reduce and restrict the spread of pests and diseases. Rejuvenation of fields is appropriate, is important, to replace an older and susceptible varieties by new and more resistant coffee trees. Also, the further development of the genetic material, as mentioned before, in coffee growing will be very, very important, as much as the further development of financial systems to get farmers really an opportunity to get access to credit that enables them conducting the investments that our sector will need. I would like to present an initiative to you, an initiative which is called Coffee and Climate, just as the name of this presentation. This initiative is starting to work on these subjects. And we have put out the vision there, which is enabling coffee farmers to effectively respond to climate change. We do that by implementing a project or a bunch of activities, basically, that combines state-of-the-art scientific know-how with very pragmatic farming methods. It offers hands-on solutions for farmers, which are generated together with them and other partners. And we are starting to develop the network I was mentioning in order to connect much better our information and our knowledge in the coffee sector. And most important, we work with a completely pre-competitive approach. We really try to involve every different layers who form part of our value chain. Founding members to this initiative are very known coffee roasting companies, trading companies, It's Paulik from Finland, Jojo Hansson from Norway, Neumann Gruppe from Germany, Löfberg from Sweden, Chivo from Germany, and Lavazza from Italy, together with the German government GIZ, who started this initiative in 2010. And I'm very happy that Michela Stano from Lavazza, after my presentation, will also address you with a couple of words, highlighting the importance of this initiative from the perspective of a roasting company. New partners that have joined the initiative over time are Frank from Croatia, the Ecom Group, Tim Hortons from Canada, and as of recent, also the Swedish government by their development agency called SIDA. We have an implementing board which is composed of our foundation together with CABI. You might know Peter Baker as one of the researchers quite active in the coffee sector of giving emphasis to the need to act and to react to the challenges associated with climate change. So he forms part of our executive committee together with a colleague from GIZ. 3 years is the period of duration. We started in late 2010, and we unfortunately only have another year left before we will finalize this current project phase. It started as a public-private partnership with implementing pilot projects now in 4 different countries. Guatemala, where we actually act in the Trifino triangle between Guatemala, El Salvador, and Honduras. Brazil, where we implement in the state of Minas Gerais. In Tanzania, where we are in the south, in Beja. And in Vietnam, concentrating on our operations in the area of Dak Lak. Our operations always start with a comprehensive assessment of the risk. We use a methodology which we call triangulation, which basically brings together the information and the perception and the observations of farmers, of scientists, and of extensionists who are active in the field level. This gives us a quite comprehensive and a quite good view about the elements that are important in this particular area. So we create a regional risk assessment, so to say, which starts then also to triggering further investigations about what elements and what practices might be suited to address the challenges and the risks that have been identified. This we do within a more comprehensive framework, which is called a risk and opportunity assessment. So we have a methodology with which we can start being operative very pragmatically at farmer level. So what kind of information does this exercise generate? I will not go into very many details, but just give you an overview in which direction we are currently working at field level. Triangulation processes have been conducted in 3 countries, in Brazil, Guatemala, and Vietnam, and we are currently implementing it in Tanzania, but information will come only within, let's say, a month's time. For this area of Sul de Minas, the climate-related risk elements identified are rising temperature, well, what a surprise, prolonged dry periods, strong rains, which led to observed increases in coffee wilt, in the spread of FOMA diseases, in smaller bean sizes, and definitely also empty beans at times, altogether reducing the productivity potential in the farmer fields. For Trifino, the climate risk elements look similar. Rising temperature, here the storms are more severe, longer rain periods are observed, which lead to an increase in landslides, infrastructure damage, and a massive spread of leaf rust, which also spreads now to altitudes where it has never been observed before. For Dak Lak, the climate risk element, again, it's rising temperature, it's irregular rain and dry periods, and unfortunately also a falling groundwater level, which further adds to risk. As consequences, farmers observe lower pollination rates, higher evapotranspiration, and difficulties in coffee drying. In all 3 places, farmers also report of an increase in their production costs. In some places, due to more need of weed controls, more frequent weed controls, but also further or an extended picking period where they just need to harvest coffee over a longer period of time. Again, a cost factor for them, in particular if they employ external labor. Also, these processes lead to identify adaptation priorities and pave the way for further working together with the farmers in these regions. For Sur de Minas, it is the use of ground cover, water harvesting, measures for erosion control, the use of more vigorous plantlets, and the establishment of windbreaks that were identified as, so to say, no-regret measures. Measures which are always good to apply in order to enhance the resilience of a production system. An innovation was also identified in Brazil, which is the application of gypsum. And you see it on the upper slide. It is high dosifications of gypsum given to the plant at a very early stage of development. Gypsum has the characteristic of mobilizing nutrients and shifting them down, further down to subsoil layers. And the roots, they just follow. As the plant is early in development, the roots are growing deeper and deeper. And in places where this technology has been applied in Brazil, coffee roots were as deep as 1.5 to 1.8 meters. And these are levels definitely which are always moist, even in times of dry, very dry periods. The project further experiments with different mulching systems to also enhance the water infiltration and to better protect soil moisture. For Trifinho, better rust control and the use of rust-resistant varieties are suggested, as well as the use of cover crops to enhance the resilience of the production system. The project will also work on zoning and screening risks at different altitudes in order to much better tailor-make the different coping opportunities towards the associated risk. Farmers feel important to work on measures for enabling better emergency response in these areas, and these shall include better risk analysis and also the development of early warning systems to just get better prepared and develop protocols which will enable a fast reaction. The pilot project also wants to experiment with gypsum, as this technology seems to be appropriate and interesting, at least for some areas in this region that also experience drier periods. For Daklak, the introduction of ground cover and the use of efficient irrigation systems are identified, again, no regret measures. Experiments are also foreseen for centralized coffee processing and for the use of simple processing for drying in particular, and also the use of drip irrigation systems to become more efficient. All projects, although mentioned here for Vietnam, will consolidate and look for more data. Meteorological data, but also data that will enhance our knowledge about dynamics, groundwater level development, as well as the spread of pests and diseases, like here in case of Vietnam, the cicada. From the compilation of first findings, it gets obvious, and I was mentioning it quite often, no regret measures that are appropriate. I would guesstimate that about 80% of what we are, together with farmers, identifying as measures appropriate to mitigate risk that they associate with climate change is best farming practices. It is best farming practice, it is sustainable practice of coffee producing, coupled definitely with a close following of the socioeconomic situation. I would guess that probably 20% are really innovations, new practices, or new instruments that might then be imminent for the particular reasons. In Brazil, we have developed another tool within the scope of this project, which is a cost and benefit assessment tool. This tool can portray the impact, the economic impact of a change in practice. It works with a number of assumptions which we consolidate together with stakeholders in the area. An economist is involved. And we can see that from the recommendations that were mentioned for Brazil, some of them have a rather small and tiny impact. In particular, when I look into mulching compared to the non-project environment, which is basically business as usual in that area, you can see that a slight increase in the economic situation is feasible through mulching. Much better is the increase through what we call the with project situation, which is the application of best practice. And then further elements can add to that, like for instance the application of gypsum. The dotted curve in the upper segment is irrigation, which also was a recommendation for places in Brazil. But you can see that with this technology, definitely a heavy investment cost in the beginning is associated. And you don't know in the long term if water will be there available to really support this application in all places. But it's important that these tools get associated with the measures, so that together with the farmers and with the other partners, the other stakeholders that we invite to our projects, we can really get a clearer picture of what likely economic impacts these recommended practices might have. And at the same time follow track through the implementation by monitoring what is going to happen. All information that we are able to collect within this project is being pooled into a toolbox. The toolbox is a framework. It's a platform consolidating the experiences, consolidating practices, consolidating also manuals, materials that we are using, which will be available for all members in the coffee sector. It's going to be online. We are currently in the phase of programming the software for bringing it on the internet. And the launch is foreseen for early 2013. Probably we will do it at the AFCA conference in Kampala. A quick look at the structure of the toolbox. We have analyzing tools. As I was mentioning already, the risk and opportunity assessment, the triangulation, the cost-benefit assessment, and also our monitoring and evaluation system, which we are developing currently, will form part of this analyzing tools, which will be available to everybody in the coffee sector through this website. We will have enabling tools, sensitization workshops, which we conduct with farmers, planning exercises to plan together again with farmers and their supporters the development of the production systems and the adaptation strategies. We will also put in financing and support mechanisms, which we are currently exploring in some of the places like Brazil, but also in other places where we see that a lot of elements are there which can make credit operations become much more accessible for small-scale farmers. And maybe we can connect them with insurance systems to just reduce further the risk elements that banks associate with lending into the agricultural sector. We will have adaptation tools for all these different climate phenomena. For drought in particular, we will have tools looking into shade, looking into mulching, looking into water harvesting and drip irrigation. All these tools will be described together with case studies, together with videos, together with photo material, so that a lot of information can